Hi, this is Glenn from Endless Innovations again. We're starting off the new year here, 2015. Been a little under the weather the last couple of days, so we're a couple of days behind when we actually wanted to start these video series. But for this year, what we're going to do is something a little different. You've probably seen some of our videos through the Machine Apparel Company, Mud USA. That's where we've been publishing a lot of videos and some of the projects we've been working on. And those have been primarily customer-driven projects. But for right now, what we're going to do for this year is something a little different. We're actually going to use Endless Innovations, which is our primary company, to actually sponsor different style of videos. Basically, these videos are going to be more educational videos. We're going to try to bring some projects in that aren't necessarily customer projects. These might be some of our projects, like this Jeep here. We're doing some things with this Jeep to get it ready for next year, and we're going to pull some projects off of this. And it's really to drive some of the key factors of what we're trying to really promote with our business, which is manufacturing, design, US-made products, things like that. So we're really going to use these series of projects to get more people involved from the community, from different industries, to actually work with us on these projects, and then let them use our shop, our software and things like that to actually get an experience of what it is to actually work in a manufacturing setting. So there'll be more detail on how we're going to do that. There's going to be some design projects down here. There's going to be some design competitions down here. There's going to be some lessons, a whole gamut of different things for this year. Again, it's really a different approach from actually just showing customer projects. So the first project that we're working on, which is really a personal project in some sort, again, we're going to use some of the parts from these projects as reverse engineering projects for learning. So this is the Jeep that we started working on a couple months ago, and we just got into just videotaping some of the things we're going to be doing and showing some of the projects. So what I'd like to do now is kind of just show you what we've been doing on the Jeep here, and then where we're going to go and how we're going to use this as a tool to kind of promote what we're trying to do with the different lessons, things like that. But what I'm going to have to do first is really just go back through some of the pictures, because again, I don't have the video of everything we've done on this so far, but I do have some of the still shots of where it was up to this point and some of the things we were trying to do. So what I'm going to do now is just kind of go through those images and then let you, and then explain some of the things of what we've done. So stay tuned. Alright, so here's a quick photo series of where we stood when we actually started working on the Jeep. The first picture here is just showing the full Jeep. This is when we got it into the shop. Didn't do any work onto it yet. Just trying to get a plan together of what we're trying to do. The next picture here is just showing this rear tire carrier that we built. We wanted the Baja style rack, and so we put this one on there. This was done 12 years ago. It really gets in the way of when you're trying to look backwards, so we're going to replace that, do something completely different back there for the tire carrier. The next one here is really just showing the picture of the bumpers and the side steps and some of the running gear we took off. This is going to be on Craigslist in case you want to buy it, but we did get rid of that. All the seats are out and things like that at this point. This is just a picture of the carb with the headers. These are the headers that we replaced. This is the Holly 250 that we actually wanted to replace with the throttle body and the valve cover. You can see that we got the new valve cover. Is going to be replacing that plastic one. These are just a picture of the stuff that's actually removed, the bump and the bumper and the step guards. This is a better picture of the headers. You can see that the standard, or the intake, is actually sitting on the wheel there. But the headers is really what we wanted to get rid of at this point, just because of the O2 sensor. The next one is actually showing just the new exhaust manifold we put on, the stock manifold, with the O2 sensor in there. You can see that it's picking up all the collectors at this point, so that's really where we wanted it to be. For this throttle body we were putting on, and you can see the single tailpipe going back to, which we think will make it a little easier for us to deal with. And this last picture here, this is just something we threw in there for fun. This is actually during the November storm we had here, the thing that was all over the news. This was our parking lot. Those were my tire tracks coming in with my pickup. That was the only way we could actually get into the shop. So that's it for the stills. That's kind of where we picked up with the videos. So stay tuned. We'll get back to the videos, and then we'll keep moving on in this project. Okay, so now that you've seen some of the still pictures of where we started, some of the things we've already done to the Jeep, let me just take you around the Jeep real quick, show you what we've taken out of the Jeep, show you some of the things that we're going to try to do, show you some of the projects we're going to actually try to work on, to show you how we design it, how we manufacture it. So let's just take a quick walk around the Jeep and I'll show you where we're at. Alright, so basically, like you've seen in probably some of the still pictures, the thing we really wanted to do with this Jeep, again, we're going to do some company-sponsored jamborees, some off-road events for next year, so this Jeep really did need some TLC to actually get it up to speed to what we feel was going to be adequate for some of the things we wanted to do with it. So the big project we wanted to do on this Jeep was we wanted to get rid of the carburetor, some of the wiring, and put a throttle body on this. So, you know, we do have right now the Howell throttle, boy, I spit it out. The Howell throttle body on this Jeep. We did put that on. We do have a new valve cover. We cleaned up some of the wiring. We went back to the exhaust, the standard exhaust manifold for this Jeep. And the reason we did that was, you've seen in some of the pictures, we did have headers on this Jeep. And with the Howell electronic system, it does use this oxygen sensor right here to do some of the tuning. And the way that the exhaust manifold or headers were set up is they went down to 2 different collectors for 3 of each of the cylinders. So I could only put that oxygen sensor in one of the collectors, and I just felt that if we were only picking up 3 of the cylinders, we might have some tuning issues and things like that. So I elected to just go back to the stock exhaust manifold with a single down tube going back down the back. You can see that right here. This standard straight tube going in the back, single tube going back there. And we got some things we have to do on that once we get underneath to make some fits. Again, we did put a new valve cover on here. Got rid of the plastic one. Cleaned up a lot of the wiring. There's still some wiring here that we still have to deal with a little bit. I'm not sure all the wires we need to use yet. And on the inside, we haven't done much yet. You can see over there, that's the stock or the new computer for the throttle body. And if we go over this way, this is the exhaust system I took out. Like I said, it did come down to 2 collectors in the back, to a catalytic converter, and then a Flowmaster muffler. It sounded really nice, but right now it's not going to be something we can use. And just to give you a quick view of what we took out, this is some of the stuff we took out of the Jeep. This was the Holley 250 carburetor, some fuel pumps, a whole bunch of wiring. This is all the wiring that we took out of the Jeep that we think we don't need anymore. We'll see once we try to start it someday. Just a bunch of accessories, and here's the, oddly enough, quick story on this. This is actually the first part I ever machined. It was actually, I did it on a manual Bridgeport and a lathe, and this was done, boy, I hate to tell you, but it was done almost probably about 18 years ago. And this was the manifold, or this was the adapter that allowed the Holley carburetor to mount the standard intake on the Jeep. So yeah, that was a long time ago. So anyways, this is the project. One of the things that we have to do on this project, and it'll be the first thing that we actually start talking about once we get into this, is that, I don't know if you can see it down there, you probably can't. Yeah, it's going to be hard. Let me go underneath here and I'll show you what we're going to do next. Okay, so I'm under the Jeep now, and one of the things that came with this fuel injection system is this electronic fuel pump and the big cartridge filter on the back here. And one of the things with this installation is that you have to figure out somewhere to mount this this fuel pump, and they give you a little strap clamp with a little rubber insert in it to actually mount this to the frame. But you know, I mean, we have a machine shop, so you know, we like to make things when we can. So what we're going to make here is a bracket that actually holds this fuel pump up against this plate right here. There's 3 studs coming out, and this is actually from the shackle reversal kit that I put on this Jeep. So we're going to use one of these bolts here, or one of these studs coming out of here, and a bracket to actually mount this up alongside the fuel rail here, or alongside the frame rail here, and hopefully, you know, we can design it such that it keeps it off the frame rail a little bit and gives us good access to it if we need to replace or do some work, and then also allows us to get the fuel filter out. So the first project that we're going to do is we're going to be designing and making this bracket. I already took some measurements off of this reversal kit, and I'm going to use this one stud here, and hopefully that'll be enough to give us the bracket that we want. Like I said, I'm still a little bit under the weather here from, I don't know, some kind of a bug I got, so we'll see how far we get today, but that is the first project we're going to do on this Jeep as far as for the video series. So I'm going to shoot over up to the office here where the computers are, and then we're going to do some modeling. Alright, see you in a bit. Okay, this is Glenn again. We're back here in the office now. I took some time here to design up a quick bracket for that electronic fuel pump we were showing you earlier. Because it's only going on the frame rail of a Jeep underneath the, we didn't make it real fancy. We didn't spend a lot of time coming up with some real cosmetic looking bracket. It was really for function. So I'm going to walk through exactly what the bracket looks like, what we're planning on doing with it, and then we'll go back in the shop there and see if we can't start machining it up and see what it looks like. So let me bring you a little closer here, and we'll go through the model, some of the master cam, what I did, and then we'll get into the back and see if we can't make it. All right, got the camera. All right, so what I ended up doing was basically just made a real simple bracket here. Basically, this surface here is where the fuel pump's going to sit, and I did oversize that a little bit because I do want to put this neoprene in between the fuel pump and the block. Just to help with vibration. I know there's some, with the electronic fuel pump, sometimes if they get too much vibration through them, they suffer a little bit. So I figure, we'll make it a little bigger, and I'll stick some of this in there. So basically the way this is set up is, if you remembered, on the frame we had a stud that goes through here. There's a little cutout in the back here. Basically that's for the little nut that comes off the stud. In order for this surface to touch the frame, it has to bypass the nut that's actually on the stud right now, so that's what this little cutout will do. I will have to deal with this radius once we get into the shop, because the way I designed it was I designed it with all 260 radiuses all the way around, just so I could use a 1/2 inch end mill and not have to deal with anything major. But I will have to cut this out and make this a little more square cornered here, just so we get the nut clearance we want. On the bottom here I have, let's see if I make it a little different view here for a little. So in here I have some clearance holes for some 1032 socketed cap screws. And basically what I'm going to do here is, once this is machined as one piece, I'm just going to come through here with the saw, bandsaw, just cut it in half, and then I'll just true up those two surfaces on the mill. It's a lot easier than making two separate pieces and trying to get them to match. It's a lot easier just doing it this way for this particular application. So that's really what the bracket looks like. Like I said, nothing major there. Just a through hole, pocket for the electronic fuel pump, and some clamp holes so when it's cut in half we can clamp it together. Just to show you real quick what I did in Mastercam over here. This is basically the Mastercam file that I used. There's a couple different ways that I do Mastercam. I started Mastercam a long time ago, so I used to always bring in 2D DXF files from a modeling package and then run my tool paths that way. Sometimes it's a little more difficult because you have to think about the depths you're working with. So, some people might look at this and go, geez, why didn't you just do it as a 3D model? Yeah, I could have, but I figured, for this application it was quick enough just to do it as a 2D a DXF file, run my tool paths around it, and then get it set up, quickly and ready to go. So basically that's all I'm doing here is this is the block I'm running. These little blue lines going around here represent the tool path. So if basically I run this would be the block material I'm starting with, which is basically, I'm going to start with this 1 inch thick piece of aluminum. The clamp is only 3/4 inches thick, but the nice part about it, if I do 1 inch, it gives me about 1/4 inch to hold on to in the vise, so I can basically contour this as one piece and then cut it off and then just fly cut the backside to get it to size. Then trying to use a piece of 3/4 inch and hold it down with clamps and things like that. So basically this is my block for all intents and purposes. So if you run the tool path, let me slow it down a little bit. So basically that's just a drill hole that I'm starting with, so when I do my pocket with the 1/2 inch end mill, there's somewhere for it to go. So basically, this is what it's going to look like. You know, nothing, like I said, nothing fancy a hole. I added some chamfers to the outside just to kind of break the edges. So that's really the tool path that we're going to run out on the machine. Over here you'll see that, you know, these are the tools I'm using. 1/2 inch drill, 1/2 inch end mill, and then a 1/4 inch chamfer mill to put the pockets and things in. We will have to go and do this as another program to put this hole in. I might elect just to do that on the manual track machine, milling machine, as opposed to setting it up in the CNC. I think once I have the contour. Same with the holes, the 1032 holes in the bottom. I'll probably just do that on the manual track machine. There's no point in really setting it up in the CNC to do that. That's pretty straightforward. So with that being said, we'll take this block now and we'll get it out in one of the machines out there. I'm not sure which machine I'm gonna run it on yet, but we'll get it out there, we'll get it set up, and then we'll start cutting some chips. So out to the floor we go. Hey, this is Glenn again. Okay, now we're back out in the shop here. I decided to run this piece here on the bracket. I decided to run it here on one of the Kiwas. The reason I did that is that, unlike some of the newer machines we have in the shop here, the Kiwa doesn't have any probing systems on it, so you still have to find the edging material and do some of the hands-on things that the newer machines kind of take for granted, I guess. With the probing systems, it does all your edge finding and all your top finding for you. On the Kiwas, since they're a little older machine, you still have to do a lot of that work, and I thought it'd be good to show that on these machines, as opposed to just using the new machine and just let it do the work. So this is the Kiwa here, Pro 510, that we're going to use. It's one of two of them we have here in the shop. Really good tight machines, real powerful machines. You know, we do a lot of heavy work on these machines, and they've been doing fine for us for a lot of years. So let me just show you the machine real quick, and I'll show you what we're going to do, and then I'll break off a little bit so I can kind of get it set up so I'm not spending a lot of time, but at least let me show you what we're trying to do right now. So this is the machine we're going to use. It's just a 40 tapered machine, 16 tools, automatic tool changer. It's an older machine, like I said, but you know, does a great job for us. So I already loaded the program. This is the program up here. All right. This is all the G code for the program. That actually is going to run the tool paths that we were looking at. And the way that this machine is set up is basically we're going to put the piece of material in the vise, and like I said, I've left a certain amount of material so I can hold on to it. I don't know if you can see that little black mark there, but I hit it with a Sharpie and then I scribed it a little more than 3/4 of an inch down. That way I knew how much material I could hold on to while the tool was going around the part, and it won't run into the vise. So I've already loaded a set of parallels in the vise here, and what that's going to allow me to do is it allows the material to set up nice and square, so when you set it in the vise, I can check my witness mark here and see that my scribe mark is sitting above the vise job. So I know when the tool path goes around a little bit more than 750 thousandths down, I'm still going to be able to get, you know, I'm going to get the cut I need, and I'm not going to hit the jaws. So that's how I'm going to set it up. The 0-0 for me on this part is the edge of the part here, this corner. So I'm going to be touching off this side and this front side here to get my 0 position. And then the tools I'm going to be using is going to be this 1/2 inch end mill, this 1/2 inch drill, and then this little, it's hard to see, chamfering tool to go around the edge of the part. So those are my tools I'm going to be using, and then I'll show you how I touch them off. I'll get a couple of them touched off and zeroed out, and I'll show you how that operation actually works, and then we'll go from there. So now what I'm doing here is I'm just getting this in there, getting it tightened down. Just pound it, because you want to make sure when you get your material in here that the parallels are nice and tight up against the material. So you give it a couple good whacks while you tighten it down with the vise. And now what I'm going to do is I just want to get this surface nice and true. So when I touch my tools off, they're working off a nice square surface. So I'm just going to real quick hit it with a big fly cutter here to get a nice surface. So okay, now that we got a fly cutter surface, we got a nice looking surface here. It's nice and smooth, clean looking. If I do a quick measurement off the block, you still see that I'm over 750. I'm only going down about 755 with my tool. So I'm still about 5 to 7 thousandths away from the jaw here. So that's more than enough. Make sure it doesn't hit the jaw. So we'll get real close to the jaw when we cut, but we won't touch it. So next thing we got to do is we got to touch off our tools so they know where to cut to when we're running our program. So I'll show you how I do that on one tool, and then I'll set the rest of them up, and then I'll cut back in and we'll just start cutting the block up. So the first thing we're going to do is tool number 1. We'll touch that off, and then we'll go from there. But we got to get tool number 1 in the spindle so we can touch it off. So let's do that. So what we do here is basically you bring the tool down to the block, and you know, a lot of people use shims, things like that. So typically what you do is you just bring it down close to the block, you put it in a real fine setting, and then you take a piece of paper and you put the piece of paper under the tool to the block, and you just shake it around until the tool actually touches and the paper stops moving. That way you know you're within a thou or two from the tool, and then you can zero your tool out there so the tool knows where the top of the block is when it's cutting. So right there, you know, the tool's caught up pretty good. Now I'll go back to the controller. I'll put in the code I need to actually zero out that tool, and that tool will be zeroed on the top of the block, and it'll know where to cut from for its depths and positions. So I'll do that for the rest of the tools, and then I'll come back up and we'll edge find the block, and then we'll go from there. Okay, so I got all the tools touched off. Next thing we're going to do is we're going to do the edge finding with an edge finder. And this is an edge finder here. And the way this tool works is basically, if you can see down the center here, this little tip here is eccentric. It actually moves off center. And the concept behind this is that you set this up so that the edge finder is running off center. You spin the tool around, and then as you move this edge finder towards the part as it's spinning, it'll start to move towards center, and as soon as it gets to center, it'll run concentric with these two diameters. Then you continue to move it, and then as soon as it pops off center, that's technically the edge of this diameter right here. And this diameter is ground to 200 thousandths, precision ground to 200 thousandths. So once it goes off center coming in the other direction, you know you're 100 thousandths away from the center line of the spindle. So basically you bring this off the part, you move it over 100 thousandths, you zero out your controller, and then you know you're in line with the spindle. And I'll show you how that's done right now, just so you can see it. So basically you get your spindle running. Get the edge finder to the edge of the part. And then what you want to do is you want to hit this so it starts to run off of center. I don't know if you can see that or if it's... Like they're a little tough. Let me move this camera up just a little bit. Maybe a little better. So basically it's running out of center. So now you start to move the part towards the spindle, and you'll start to see the edge finder going less and less off center. See how it's starting to come into center, and then you watch it until it just goes off center again, just like it did there. It might have been hard to see because it actually went towards the back, but it's now running off center, so I know I'm at the edge of that edge finder. So now I just move this off the part, I zero out my controller, I zeroed out my controller. Now I'm going to move this in 100 thousandths. Right there's 100 thousandths. So now that is running right on center of the spindle. So now I know that this is the edge of my part is at the center line of my spindle, because in the program I made this corner my 0, 0. So I need the spindle to be right at the corner of this part for my program to run. So I'm going to do that for the other side, and then I think we're ready to run the part. Alright, I think we're ready to run. I just got the camera out of the machine, just to keep it away from the coolant. So let's run it and see what happens. Here we're just throwing the 1/2 inch hole. And again, we're not going crazy with speeds and feeds here. This is just a part of the production part. We're not worried about cycle time and things like that. So, there's the 1/2 inch hole, which is basically the new starter hole for 1/2 inch end mill right above the milling. So it's going to make a bunch of passes around here at different cut widths, and then again, if we would have did this on one of the other machines, we would have did some high-speed machine maybe, and really whip through it. But again, this is a good way to show some of the older machines that are just capable of doing everything you need to do, and you still get the same result. center pocket in now for the fuel pump. And now we're doing the last operation. This is the chamfer mill. So we're just going to run that now, and that'll be the last stop. We'll take a look, see what it looks like. Okay, so there it is, finished up so far. So you can see like the nice chamfers around the outside. What I'm going to do now is, you can see how close I got to the vise here, which is fine. I mean, it didn't hit the vise, so that's all that matters. So what I'm going to do now is I'm going to put it on the bandsaw, and I'm just going to cut kind of a lot of this material out close to the profile of this. So when I flip it over to cut it off, I don't have all this big material hanging off. It just makes it a little easier when you're flat cutting the other side. And then what we'll do is we'll recenter this part up using this diameter here instead of the edge. And then we'll run that chamfering program again on the other side just to clean that other side up, just like this side. But we'll have to use this center this time, but just because we don't have the corner anymore. So yeah, that came out pretty nice. I think it's going to work out really well. So I'm just going to take it over to the bandsaw, chop it up, and then we'll bring it back over here to the mill, and then we'll fly cut that side down. So here's what we have after cutting with the bandsaw. You can see I just have a bunch of rough cutting surfaces here. So now what I can do is I can hold it in the vise on these two surfaces this way, fly cut the top of it off, and then leave this shape here. So that's what we're going to do now. We're just going to set up in the vise, and then yeah, fly cut the back side and get this thing to shape, and then start on the other holes. So that's where it sits right now. Okay, so what I did now is, I got my fly cutter in here, I got my block clamped between the two surfaces that were machined. I put a different set of parallels in here so I could keep it, so I could get a nice bite on the block that I already machined, but leave enough that I can cut this section off. I know I want my block about 750 thousandths thick, so what I did was, I brought my tool here, my insert, down, I left my parallel sticking out of the vise a little bit, because I know this is sitting on top of my parallel. So I came down and I touched off my insert on the top of this parallel the same way I touched a tool off on the top of the part with a piece of paper, and I zeroed my tool out here. And then what I'm going to do is I'm just going to bring this up about 760 thousandths of an inch, take a cut, get rid of most of the material, and then bring it down to 750 and take it right to size. So that's just a little way of getting this to the size I need it. Zeroing it off the parallel, bringing it up, and then cutting it. So we'll do that. We'll get this to size, and then we'll re-zero the chamfer mill so we can run the chamfer around the outside of this, and I think we'll be done in the mill. So let's get that going, and we'll go from there. Okay, so there it is after fly cutting it. Now we got a nice surface here, but we still have these real rough edges now from the fly cutter and material, peeling over. But we knew that was going to happen, which is why we were going to chamfer it after we flipped it over. So I flipped the part, oriented the part in this configuration, and I did another real quick program on Mastercam to make my origin at the center of this hole, and then ran the same chamfer program around the outside. So what I'm doing right now is I'm just using my coax here to actually find the center of this hole. And basically, coaxes are, I prefer coaxes over indicators sometimes because you get a lot more travel out of a coax. And as you spin, let's see if I can show you this, as you spin the spindle around, you can hold the dial of the coax stationary in front of you so you can watch the dial. Because what you're trying to do here is to get the hole centered. You're setting a 0 here on your dial, and then you're rotating this around until you get that needle to move very little. Right now it's moving about 5/10, which is fine for what we're doing on this particular part. And it's nice with the coax because, like I said, the dial can stay in front of you. So right now I've got the center of the hole figured out. So what I'm going to do now is just put in the chamfer tool. I've already touched it off, and then we're just going to run the chamfer, and then we'll be done with this part in the CNC. So let's do that right now. Okay, so we got our chamfer tool in there, and let's just run it, see what happens. Let's run it now and see what happens. And so there it is. So I think we're done in the machining center. A nice chamfer around the whole part, all the way around. That's what we're looking for. So let's take it out and figure out what we're going to do next.